Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to start chapter 10, section 10.1. But first, I just want to say if you are watching this video later on YouTube and you did not make it here this morning because you couldn't find the Zoom ID, I messed up and accidentally deleted the old one. And so we have a new ID number and I emailed that to all of you students. So if you check your email and can't find it, email me and I'll send it to you. Anyway, with that, we're going to move forward. So we're going to take a look at section 10.1. So here we go. We're going to look at something called the square root property. In the last chapter, we solved equations containing radicals by squaring or cubing both sides of an equation. In this chapter, we're going to kind of go the other direction. We're going to take the square root of both sides of an equation. Take, for instance, the equation x squared equals 9. Can you see that if x was 3, this would be true? 3 squared equals 9. But if x was -3, this would also be true. -3, the quantity squared equals 9. Therefore, for the equation x squared equals 9, we get two solutions. X is 3 and x is -3. Any questions about that example so far? All right, so what we're going to do to use the square root property, we want to have the equation in the form it is here, where on one side of the equation, we have a perfect square that contains the variable. And on the right side, or the other side of the equation, we have a constant. Our next step is to take the square root of both sides of the equation. So then we get x equals 3. But recall from the previous example that there are in fact two solutions. So what we do is when we take the square root of both sides of the equation, at that point, the constant side of the equation, we add a plus or minus outside the radical, which then we get the following. X equals plus or minus 3. And this is acceptable notation in the mathematical community. However, WebAssign doesn't have this notation as an option, at least not that I'm aware of. So you'd say x equals 3, comma, -3. Or x equals 3, x equals -3. All right. Any questions about this example? Okay, so let's take a look at some other examples. Let's take a look at the following equation. W squared minus 47 equals 0. So we need to get it in that special form where we have a variable or a term containing the variable, which is a perfect square, equal to a constant. So in this case, we'll add 47 to both sides of the equation. So now it's ready. W squared, make a better W than that, hopefully. W squared equals 47. So now we'll take the square root of both sides of the equation. Don't forget the plus minus. If you forget that, you're basically throwing out half the solution. So you want to keep that in mind. So W equals 47 and W equals, the square root of 47 and W equals negative the square root of 47. So there's our two solutions. Okay, another example. U squared minus 24 equals 0. So once again, we'll get it in that special form by adding 24 to both sides of the equation. So now we have a perfect square containing a variable equal to a constant. We'll take the square root of both sides. So we get u equals plus or minus the square root of 24. However, when we have our radical answers, we need to go further if we can, and that is to simplify those radicals. So for instance, the square root of 24 is the square root of 4 times 6 is 2 square roots of 6. So the final answers, u would be plus or minus 2 square roots of 6. So u equals 2 square roots of 6 and negative 2 square roots of 6. And there you have those two solutions. So you don't want to stop here. You want to keep going and simplify the radicals. All right, let's see here. We have this problem. Quantity x minus 1 squared equals 4. On the left side of the equation, we have a perfect square containing a variable. So we don't want to multiply this out. We want to take the square root of both sides. So then on the left side, we get x minus 1. On the right side, we get plus or minus 2. But we're not finished yet. We need to isolate x. So we'll come in and add 1 to both sides of the equation. So x equals 1 plus or minus 2. So x equals 1 plus 2, which is 3. 1 minus 2 is negative 1. So x equals 3, comma, and negative 1. Okay, let's see here. We have the quantity s minus 7 squared equals 9. So we have a perfect square on the left side of the equation containing a variable and a constant on the right side. So it's already in the form we want. We take the square root of both sides of the equation, and we get s minus 7 equals plus or minus the square root of 9, which is 3. Then we'll add 7 to both sides of the equation. So s equals 7 plus or minus 3. 7 plus 3 is 10. 7 minus 3 is 4. So s equals 10 and 4. And then here, let's see, it says, let f of x equal the quantity x plus 5 squared for what value or values of x is f of x equal to 3. So substitution, we're going to put 3 in the place of f of x. So our equation becomes 3 equals x plus 5, the quantity squared. You don't have to do this, but I like having my perfect square with a variable on the left side of the equation. So I'm going to write it like that instead. Just turn it around, okay? Then I'll take the square root of both sides. And we get x plus 5 equals plus or minus the square root of 3. Solving for x, subtract 5 from both sides. X equals negative 5 plus or minus the square root of 3. So x equals negative 5 plus the square root of 3, negative 5 minus the square root of 3. So there's your two solutions. Okay. Be careful not to put those in parentheses because that would imply that it's an ordered pair, and that's not the case. If you wanted to write x equals negative 5 plus the square root of 3, x equals negative 5 minus the square root of 3. But again, read the directions in WebAssign, and most likely it will say write the two solutions separated by a comma. So you would do something like that. Okay, I know this is an awful short lesson today, but that's basically it for section 10.1. So you want to get it into that special form, take the square root of both sides, make sure that you include the plus or minus, and then simplify from there. You know what? Let's do one more here. This one's a little more complicated. Okay, let G of A equal the quantity 7a minus 2 squared, period, for what value or values of A is g of a equal to 8. Okay, so once again, we're going to make a substitution. We're going to put 8 in the place of g of a. So I'm going to have the quantity 7a minus 2 squared equals 8. Okay, and again, I put my perfect square on the left side of the equation because that's the side I like to have it on. Then I'm going to take the square root of both sides of the equation. Okay, on the left side, I'm going to get 7a minus 2. On the right side, I'm going to get plus or minus, and I'm going to go ahead and simplify the square root of 8 to 2 square roots of 2. Okay. So next, I'm going to add 2 to both sides. So now I've got 7a equals 2 plus or minus 2 square roots of 2. Then I'm going to divide both sides by 7. So I'm going to have a equals 2 plus or minus 2 square roots of 2 all over 7. So to write those as separate answers, a equals 2 plus 2 square roots of 2 all over 7, 2 minus 2 square roots of 2 all over 7. Now, make sure that you put this whole thing in the numerator, okay? You don't want to write something like this, okay? Or like this, but that fraction bar should extend over the entire or under that entire numerator, okay? Any questions about that? All righty, well, that's it for today. So for tonight, you've got section 10.1. I'll be back at 1:15 with an office hour. Should you have any questions? With that, I'll go ahead and stop the recording.